Okay, so let's look at the derivative for your AS levels, differentiation. So just a note, differentiation and finding the derivative, that just means the same thing. Okay, so if you asked find the derivative, or if you asked to differentiate, it just means you need to find the slope. Now, we'll get into that later, but first of all, in your GCSEs, the basic thing you learned was the power rule, which is how to find the derivative. It's just one way, and it's the simplest way of finding the derivative. There are other ways which are more complicated when the sums get more complicated, but for now, let's look at the power rule. So sometimes when you look at a rule like this, it actually just looks sort of arbitrary and quite confusing. So let's look at an example. So where that k is, we would say put a 3. And let's say we had an x here, and we put a, say, 3 here. So when we want to find the derivative, all we do is this kn means we times the front number and the exponent together. So we would say then, oh, okay, so it's 3 times 3, and that would give us 9. And then that n minus 1 basically says take 1 away from the exponent. So we would say 3 minus 1. Now that still might look a little confusing, but the more you do it, the more simple it'll become. So 3 times 3 is then 9, and then x, and then 3 minus 1 is 2. Okay, now we don't have to write this long formula out. So we don't have to write this long step. We can actually start doing it quickly. So if that didn't make sense, so when we ask for the f of x, what we mean is we write it like this, f of x like that. Let's look at another example, but I'm going to do it with different terminology. So I'm going to say, instead of f of x, we're going to say y, because f of x is actually the same as just saying y. So we say, okay, let's make it negative 2x to the 4. Okay. So here, another way of writing the derivative is to say dy over dx, meaning change in y over change in x, which of course we know when we're finding the slope, your gradient formula is change in y over change in x. So in other words, the amount that y changes over the amount of x that x changes, sometimes called rise over run, gives you the slope. So 4 times minus 2 is minus 8, and then we take 1 off the 4 to get 3. Okay, so 4 minus 1 is 3. And so gradually, as you do these, this power rule is going to be so simple. And if you did it well in GCSEs, you'll already know it. And so you can probably then just skip to the rest of the introduction. But I'm going to do a couple more. And we're going to use a few different types of notation as well, so that you can see the different notations. Another way of doing it is if they did say y equals, say, 7x squared, they also would sometimes write y dash equals 14x. We take 1 off the 14. So let's look at one now where we have multiple terms. So let's say f of x equals 3x squared minus 4x plus 3. So now we can say f dash of x. And if you have multiple terms, you just do them individually. So 2 times 3 is 6x. 2 off the 1 comes 0. Now, when we have an x with just a 1 as the exponent, remember that 1, it's a 1 there, a ghost 1. And 1 minus 1 is 0. So anything to the power of 0 is 1. So essentially what we'd end up saying is 1 times minus 4 is minus 4. And then x to the 0 would just be 1. So anything in front of the x, if the x has just got no exponent, your derivative is just whatever's in front of the x. So if I had, say, 100x, the derivative would just be 100. Okay. So if I had a half x, the derivative would be a half. Okay. Sometimes it's shown like this. Sometimes it'll show 2x over 3. Well, this is just the same as 2/3 x. So again, derivative would be 2/3. All right, so the -4. And then if it doesn't have an x, there is no derivative. And so it just goes away. So the 3 doesn't, is no longer there. Okay, so we'll explain that now on the graph, but this would be the derivative. So we now know how to do the derivative using the power rule, which is quite a simple one. Okay, now let's look at what is the derivative. Like, why are we finding this? Okay, so the reason we're trying to find it is because we want to know certain things about a graph. Because your slope is actually very important. So I've drawn 2 parabolas here, and let's just remind ourselves, if you have a downwards, in other words, a sad face graph, it means that there was a negative in front of the x squared. Okay, and if it's a happy face like this, it would been a positive x squared. So even if you had a graph, say they told you the graph of f of x equals x squared plus 3x minus 1. Just looking at that, if you wanted to know if it's happy or sad, in other words, the parabola goes up or down, we only look at the number in front of the x squared, and we see there's a positive here. And so the positive here, because it's would be a happy face. And instead of being a negative, it would be a sad face. So that's the first thing, but that's now not part of the differentiation. That's just actually from functions. Okay, now if we look at this side of the graph, we see that it's sloping upwards, right? Upwards. Okay, so we have this is a very steep positive. So I'm going to put a big plus here. But then as we go this way, it becomes positive, but less and less positive because it's less and less steep. And so it wouldn't be very positive up here. And then over here, we see that there's actually no slope. So I'm going to just say over here, do you see that if I just draw a tangent, it would just be a straight line. So there's no slope. So we could say here would be a 0 here because there is no slope. Okay, and then this way, it's slightly negative, but then it's becoming more and more negative. Okay, so if we were to draw our x-axis of the negative x squared graph, it kind of looks like that. This being our x-axis and this our y-axis. But I'm not too concerned with that. I'm just interested in actually at the moment in the shape. Well, let's look at see how this applies to our derivative. So if we were to do f dash of negative x squared, it would be negative 2x, and we take 1 off the 2, and we get negative 2x. Okay, now if we were to make this equal to 0, we would find the gradient over here. We would find where the gradient is 0. So we would find the x value of that point. If this derivative was positive, we would find all the values over here on this side. So this would be where the f of x is positive. So the f dash of x, so f dash of x, let's do it again. Let's look at the next one. Maybe if it didn't make sense, we'll look at it again. So f of x, that's the f dash of x is going to be equal to 2x. Okay, and here we have the negative on this side. and then 0 over here. And positive, positive, it's becoming more and more positive. Okay, so the derivative refers to the being positive or negative. So in other words, a positive slope goes upwards. So if where our derivative is positive, it goes upwards, and where it's 0, it's flat. And then when it's did I say negative or positive? Positive. So positive slopes upwards, negative slopes downwards. Okay, so let's look at those examples, but now let's put it on a plane so that we can actually see that. So let's say that we had our, now I'm going to actually draw our axes. And I'm going to say, right, so that's X, that's Y. Okay, now we know that this would be the parabola for Y equals X squared. Now let's do the derivative again. Remember, it's Y dash equals 2X. So this means the slope of this graph up here. That's what we've got here. So this bit here in purple is the slope. Okay, well, let's see how this works now. So let's say that we wanted to find this turning point. Okay. Well, what we could do is we could say, well, the turning point is where the derivative is 0. So what I do is I make this 2x equal to 0. Okay. And when I make 2x equal to 0, I find x is equal to 0. And that makes sense because look, if these are all the negative values of x and these are all the positive values, then here, this is 0. And that's where the derivative is 0. So it makes perfect sense. Now, if we were to say put a negative here, so let's put negative into our derivative. So let's say that we made our derivative, let's say we made our x 1. Okay, so, well, first of all, so let's just put our 0 in. So to confirm, so if you put in 0, y dash equals 0. And so that makes sense because when you put x as 0, you get 0 slope. Now let's put in a negative value. So we'll just put in -1. That's the easiest one to put in. So y dash, so we'll say y dash equals 2. And where we see an x, we put in a -1 and we get y equals -2. So actually we know then that the slope is -2 at this point. And we see that because it goes downwards. Let's put in a slightly more negative number. Let's put in -4. So y dash, which is our gradient. So the purple is the formula for the gradient, the one in the purple triangle. 2, and if we put it a -4 in there, we get y dash, we get the slope is -8. Wow, this maths is working out because look how steep this is, -8. Now, if we were to put in, say, 1 here, then we get a +2. And of course, yes, at 1, we see that it's actually sloping upwards. And then if we were to put in +4, we get 2 times 4, which is equal to 8. And we see we have a big, steep, where it's at 4, it's very steep. Okay, so the maths is working out. So that's why we find the derivative, because the derivative allows us to find the slope at any point on the graph instantaneously. So if I wanted to find out the slope at 100, I could simply just put in 100 into my derivative formula, which I know how to work out using the power rule. I put that 100 into that derivative formula. And in this case, I will get 2 times 100, which is 200. So I know that that slope where the x is 100 is 200. Okay, so that is the introduction to your AS level derivatives.